Hi, this is Farrokh Alemi from George Mason University to talk about how do you calculate mediation effects and what is an indirect effect. In this set of slides, we show you how to ask what-if questions by, by first creating a model of real world and then manipulating that model to ask what-if questions from the model. And comparing real and revised models will then answer the what if question. Let's begin with our model derived from observational data. This model is based on a number of regressions, and we are showing it here as a network model. The main regression is the regression predicting the value of y. And this regression depends on all four variables, C1, C2, exposure X, and mediator Z. But there are a lot of other models embedded in this network. One is a model that predicts the value of C1. This is called an imputation model, where when the value of C1 is missing, the imputation can be used to replace it. There are also imputation models for C2, exposure X, and mediator Z. All of these models are part of the network model. The network can be thought of as a collection of these regression models. The network model shows both the direct and the indirect effects. The direct effects of Y are mediator Z, exposure X, and the covariates C1 and C2. But there are also indirect effects. Covariate C1 has an indirect effect through exposure X, through mediator Z, on outcome Y. Covariate C2 also has an indirect effect, from starting from C2 going to X, Z, and Y. How would you calculate the indirect effect or the mediated effect? This set of slides show you how to do so. The first thing you have to do is to create a counterfactual model. A counterfactual model is a model in which you have removed some relationships to ask what if this relationship didn't exist in the model. This kind of imagining a world in which certain things are no longer there is obviously an imaginary model, and therefore it's called counterfactual. So if we remove the arc that goes from C1 to X, we then have a counterfactual model. The parameters of this counterfactual model is estimated through regressions. Remember that exposure X in the real model was modeled through a regression in which the intercept C1, C2 were predictors of exposure X. But now we want a counterfactual model in which C1 is no longer allowed to be part of that regression. So we are removing the effect of C1. This leads to a change in the coefficient of C2. It might also bring in other variables that are not currently part of the regression equation, but in this case, in this simplified case, it's not doing so. This is the new model now. from this counterfactual exposure, the arc that goes from C1 to X no longer exists in this model. So the basic concept of counterfactual construction is that you manipulate the regression equations that are used to construct uh, real models. Instead, by this manipulation, you get to a counterfactual model. So in our real model, we could examine the effect of C1, changes in C1, on the outcome Y. Here, for example, when C1 is present, the outcome Y has 73% chance of being present. But when C1 is absent, the outcome Y has 68% chance of being present. So the change in C1 leads to 73% minus 68% change in Y. We can now compare this to the counterfactual changes. In the counterfactual model, we start with the same model, but now the link from C1 to X does not exist. Notice that now the outcome of Y is predicted to be 71% when C1 is present. And when C1 is absent, the outcome of Y is predicted to be 68%. So the change from C1 to the change in C1 from being absent to present leads to a change of 71% minus 68% change in the outcome Y. In summary, in the real model, the change in C1 led to 4% change in outcome Y. In the counterfactual model, the change in C1 led to 3% change in the outcome Y. So 39% of the effect of C1 was carried through a mediation through X. The mediated impact occurs only when the mediator is missing. So we have shown you how to answer what-if questions by comparing real and counterfactual models under specific ways in which we can manipulate the counterfactual model.